Okay, so the last rule that we have for exponential expressions is shown on this slide. And the idea here is, as you can see, the exponent can be distributed, right, over the operation of multiplication or division, like it is here, right? The exponent gets distributed. This could be thought of as another distributive property, right? Only instead of distributing multiplication or division over addition or subtraction, we are now distributing exponents over multiplication or division. Now, it's not terribly difficult to see why this is true if we, for example, take the expression AB and raise it to the third power, which means that we multiply AB by AB by AB. You see we have A times A times A, which is A cubed, or B times B times B, which is B cubed. And so the exponent was distributed. So you can kind of see how this property works. Similarly, if I was to take A over B and raise it to the third power, that would mean I multiply the fraction by itself 3 times. And since I multiply fractions across, A times A times A in my numerator is A cubed, over B times B times B, my denominator is B cubed. Again, the exponent has been distributed over the numerator and denominator of the fraction. It's a very simple property, just distribute, but it does let us tackle more interesting examples. So let's take a look. In example 4, what we are raising to the fourth power is the product of 3 and x to the negative 4 and y squared. And so what we're basically doing is we are distributing the 4 into each factor. So this next part you can do in your head. I will write it out just to illustrate what's happening. We are raising 3 to the fourth power. We are raising x to the negative 4 to the fourth power. And we are raising y squared to the fourth power. And what that means is 3 to the fourth power, well, that's 3 times 3 times 3 times 3. 3 times 3 is 9, 3 times 3 is 9, and 9 times 9 is 81, so that was easy. And here we just multiply the exponents, x to the negative 16, y to the 8th, right? 2 times 4 is 8. And notice we have a negative exponent, so we should rewrite our final answer as 81 y to the 8th, and that x will be moved to the bottom and make the exponent positive, x to the power of 16. And there's our final answer, 81y to the power of 8 over x to the power of 16. Let's go on to the next example. 2x to the negative 3, y squared over z to the negative 5, everything raised to the negative third power. Well, there are many ways to attack this problem, but the most straightforward would just be to distribute the negative 3 into each factor in the top and bottom of the fraction. So that's 2 to the negative 3, x to the negative third to the negative 3, y squared to the negative 3 over z to the negative 5th to the negative 3. Now, 2 to the power of negative 3 happens to be 1/8, but if you're not comfortable writing 1/8 in the numerator and figuring out what to do with that later, there's a little trick. You can just move this to the bottom and make the exponent positive. No big deal. We'll come back to it later. X, -3 times -3 is +9. Y, 2 times -3 is -6. Z, -15 times -3 is +15. And now we just have to tie up some loose ends. The negative exponent has to go to the bottom and become positive. And also, we shouldn't leave 2 to the third. We should really say what it is. So x to the 9th over 2 to the third, that's 2 times 2 times 2 is 8. Y to the power of 6. Z to the power of 15. And that's the answer to this question. There's nothing more that we could simplify. The two things to take note of from this example are, first, that we can distribute the exponent into every factor in the numerator and denominator. And the second, and this is a useful trick, when you see a number raised to a negative power, you don't have to worry about it. Just move it to the bottom or to the top if it started on the bottom. Make the exponent positive, just like we were doing in the previous objective, and evaluate from there. It's much easier to deal with 2 to the +3 on the bottom than 2 to the -3 on the top. Finally, I would like for us to tackle this last example. This example may seem intimidating at first, but I assure you it's not something that we can't handle. Notice that this example has everything that we have talked about pretty much when it comes to exponential expressions. It has raising an exponential expression to a power. We see there's going to be some multiplying, there's some dividing. But just like any other very complicated example, our strategy is going to be work inside out. So the first thing that we're going to do is, you see this exponent on the top and this exponent on the bottom. Those can be distributed very easily, right? We can do this distributing. We'll leave everything else intact for now, but we have 3 to the power of 4, as we saw from the previous example. 3 times 3 times 3 times 3 is 81. And then we multiply the exponents. 2 times 4 is 8, so x to the 8, and y to the -4. We will leave the next expression intact. X to the -3, y to the 5th, all over 36x to the 4th, y to the -9, and distributing the -3. 2 to the power of -3. Remember, if you feel uncomfortable about it, you can just leave it as 2 to the power of -3. We will move it later to make the exponent positive. And then we multiply the exponents. -7 times -3 is +21. So that's x to the 21 and y to the -6. And remember, we still raise the whole thing to the power of -2. Okay, so we are going to deal with that. Why don't we move the 2 to the -3 up top? Now, right, we're going to cross it out here and write it as an 8 here, right? Because 2 to the third is 2 times 2 times 2, as we've seen many times before, is 8. And let's continue. We can multiply the top and multiply the bottom. $81 times 8 is 648. Multiplying the x's, we have to add the exponents. 8 and -3 is 5. And multiplying the y's, -4 plus 5 is 1. So that's just y to the first power. All over 36, we don't have anything to multiply that by, so we're going to stick with the 36. X's, we can add the exponents. 4 and 21 is 25. And y, -9 and -6 to the power of -15. All still raised to the power of -2. Okay, well, now we can reduce. We can divide. We can simplify, I should say, 648 over 36, because it turns out that 36 goes into 648 evenly, exactly 18 times to be specific. So that just reduces to 18 over 1, and we remember we don't have to write the 1. X's, we have a bigger exponent on the bottom, so 25 minus 5 is 20. That's x to the power of 20. We write that on the bottom. And here y is like y to the power of 1, and we have a bigger exponent on the top than on the bottom because 1's bigger than -15. And 1 minus -15 is 16, so that's y to the power of 16. And the whole thing is raised to the power of -2. And if you're a little bit annoyed about raising a fraction to a negative power, I'll show you another trick that you can use. And this is because exponents, negative exponents basically mean reciprocals of positive exponents. We can just flip this fraction, say x to the power of 20 over 18y to the power of 16 raised to the positive second power, right? We can flip this fraction, make the exponent positive, because negative exponents are reciprocal of positive exponents. And now we can distribute the exponent of 2 into each term. So we multiply the exponents, we get x to the power of 40 over 18 to the second power. Well, 18 times 18 is 324. And y to the 16th squared, we multiply 16 by 2 and get 32. So y to the power of 32. And looks like there's nothing more that we can do, so that will be our final answer. I want to see this complexity being worked out just so that you can see that there isn't anything supernatural that you need to understand to be able to do this problem. Just work it one step at a time. You see you can simplify it a little bit by distributing the exponent, do that. You see that you can simplify it a little bit by multiplying the expressions in the numerator, do that. You want to take a little step and take the, the 2 to the -3, move it up top. Do that. Just every little step that you see you can do to improve your situations, just do that. Look at the problem again and see what other steps you can take. So with this, you now know everything you need to know about exponents in realm of this course at least, then you're ready to do your next assignment. Good luck.